Tired of not getting enough of sleep? Tired of waking up in the middle of the night? Well, we've got a solution for you. Introducing Meteor. Meteor is designed to help users who experience insomnia on a regular basis to improve their sleep quality. Meteor consists of two main parts, the headband and the mobile application. The headband will be placed on the head where the sensors will be in direct contact with the skin to easily obtain data. The four sensors embedded into the headband will be the EEG electrodes, pulse sensor, snoring detector, and accelerometer. The second major component will be the mobile phone application, which will collect, analyze, and display data. The distinguishing feature of our product is the presence of both active and passive measures, such as suggesting a sleep schedule, reporting abnormalities, and sending alerts. To add on to that, there will be the usage of white noise to allow the user to remain in deep sleep.
The market for sleep-associated technology is expected to cross $27 billion. Studies show that 33% of world population suffer from insomnia and 10% of them are in chronic stage. Furthermore, 40% of male and 20% of female populations are identified as habitual snorers. This allows sleep industry to grow at a rapid pace. Unfortunately, this analysis was performed before the COVID-19 crisis, thus the numbers would be affected. However, the problem will persist, and after the pandemic, the Meteor will be there to help the people as a lightweight, cost-effective solution. There are not enough sleep centers to collect EEG and to diagnose every individual in a sleep clinic, as the scale of the problem is very large. Meteor will help the doctors as users can collect data at home. The app accompanied with Meteor will be able to provide suggestions to improve when the problem is detected in data, and doctors can use the data to provide a precise treatment if the problem is critical. The Meteor will not be the only device on the market that is measuring EEG of the people and showing them the data. However, it will be the first of its kind that will detect sleep disorders such as insomnia in the people. These devices are designed for specific purposes which are not directly related to sleep apnea. A person can buy the devices such as Dream, but the functionality is limited to representing the data and telling the user slept well or not during the night. The user is free to compare the data with previous nights, but our app will do that and try to detect the problem of insomnia.
Hello everyone, my name is Yuri and I will talk about circuitries that we have excluding EEG part that will be discussed later by Gurjinder. And here you can see Arduino Pro Mini connected to several modules. Let's talk about these modules and explain how they work. The first module I would like to talk about is a power supply, which is 3.3 volts in this case. We designed our circuit to work from a low energy source in order to reduce power consumption. So we took an Arduino Pro Mini, which works from 3.3 with 8 MHz frequency. The second model I would like to talk about is a MEMS microphone SPW2430, which is used to detect the snoring, because the snoring can cause people to wake up or even diminish the quality of the sleep. We decided to use MEMS microphone over the ECM1 because it is well suited for limited space environment, such as our headband. As well, it has a lower output impedance, which will result in the higher noise stability. This circuit diagram shows how our microphone is connected to Arduino Pro Mini using the amplification circuit, as it was discussed above. Unfortunately, we have some issues with filtering out the noise currently, so it will be achieved over the Engineering Science 440 as part of prototype, as it was discussed in our requirement specification document. The next component is a Bluetooth Low Energy module, which has higher operating range, faster data transfer rate, and can communicate with both Arduino and iPhone devices. This feature can be used in the field for cross-platform support later on. The receiving pin of the Bluetooth is also protected from unexpected high voltages with a voltage divider. Here you can see a simple connection of our Bluetooth model to our Arduino Pro Mini, and as you can see there is a voltage divider of ratio 3/5. Then we have an SD card slot which is connected to Arduino Pro Mini. It is used for storing data when the device is not connected to the phone, so later on the data can be transferred to the application when it's requested by a user. Here you can see similar SD card socket which is connected to Arduino Pro Mini. The pulse sensor have a green LED which is placed over a vein. The LED emits light which will detect a blood flow when the heart beats. The blood flow is detected since the sensor picks up more light due to the higher reflectivity of the blood. Here a simple connection is shown of our pulse sensor with Arduino Mini.
Now I will start the demo of how we connect from our application to our Arduino. We will start the connection right now. So we are connected, LED is on. We received one in our command line. So we send it. So we notify an application that we are connected. Then application will send us the date, which will be used as the name of our files, where will we store the data. And now we notify Arduino that recording is done. So we are receiving some data. It's messy in the console, but it works fine for the Bluetooth on the application side.
So we are done. The data that we received is in hexadecimal format because it's easier to operate with it. Some of the data got messed up in the console, but it works absolutely fine for the application received data correctly, and you will be able to see it when Andre will show it to you later on. Please ignore last error message because it just to indicate that the code completed.
We hooked up the EEG to our teammate. Here you can see Andre in the image. We are testing how well the circuit responds to his blinking. We asked him to blink at different frequencies and we noticed the output at the oscilloscope. As he blinked faster, we can see the high frequency output with the lower amplitude. As he stops blinking, the pattern goes away. As he starts to blink slower, there is a smaller frequency wave with a little bit higher amplitude. As he closes his eyes, we don't see the pattern being repeated. We asked Andre to try to be as much relaxed as possible and close your eyes. We noticed some signals between 2 Hz and 10 Hz. We expect these signals when we try to go to sleep. When we actually fall asleep, these signals will be dominant. Our circuit can pick up some of these signals as the person is trying to go to sleep or trying to relax.
A critical part of the product is communication between Arduino microcontroller and Android app. This communication is realized using Bluetooth technology. Arduino is awaiting for a request from the application to start recording. With that request, we also send the current time. Microcontroller keeps on recording data from the sensors until another request from the phone stops it. For this workflow, the team is using homepage buttons Start Session and End Session respectively. Once the data has been recorded, the app will request to download it. Our team has decided to implement a Bluetooth service which can be executed on the background, not to impact users' workflow. In addition, Bluetooth connection class implements Runnable, which allows to run the code on a separate from the main thread. This allows to increase the performance of the application. Also, a user will be able to trigger data fetch. Let's install the application onto the phone so we can check how the data is received by the phone from the microcontroller. So the application is installed. Now the app is looking for the headband and we should see some logs emphasizing that right now. And now the app has found the band, and now we're gonna quickly start and end the session to record some data. Now we're waiting for data to for app to receive. So this data is encoded in hex and all of the decoding will be done on the phone.
Once the dashboard button is highlighted in the navigation bar, we are in the dashboard layer, which it contains the features such as the setting the alarm, which you can set anytime that you want, and turn it on or off to set it, and showing the sleeping position, recommendation, and progress report. And also it has this reminder set. One of the functionality of this layout is to demonstrate the duration of the sleep, hours that spent in the deep sleep as well. As you can see, we are in the setting layout. The main functionality is to store the user's important information such as the date of the birth, full name, height, weight, and other personal information that can be important in analyzing the data for our in the future. As you can see, we need to store our data, and we decided to use the SQL structure. The SQL is preferred since the data of the tables are constantly changing through our project. Also, we might need vertical scaling when the volume of the data stored in is growth. So this is so due to these reasons, the SQL is the preferred structure. Also, the SQL database favored by Android application would be the SQLite. Android Studio comes with the embedded SQLite database, and it's easier to implement. Plus, there would be quite few relation between the tables. Also, another reason that we didn't choose NoSQL is that I doubt we need the horizontal scaling, and also we are not expecting too many pulls right from or to database. So when we see the update successfully means that our data is updated in our database as well.
Hi, I'm Prativi, and I'll be talking about the statistics page that we created on the Android application. These three graphs will be represented using a line chart with important information displayed below them, such as the current state of sleep based on the frequency of the brainwaves. The line charts were plotted using the MP Android chart library available online. MP Android chart comes with a variety of charts, making it extremely useful for application. MP Android chart allows the developers to easily incorporate real-time readings to be displayed on the graph. The sleep chart will display the voltage readings from the EEG monitoring system against the timestamp. Then the frequency of the brain waves will be used to determine the user's sleep stage. Similarly, the snore chart will display the loudness of the snore in decibels against the timestamp.
Our team has also prepared an appearance prototype of the headband. The prototype was 3D printed using plastic as a material for the frame. We also used clay to fill the section on the forehead where all of the electrical components will be housed. We also wrapped the headband in the cloth to show what texture product should have. As this is just a prototype, the back straps are not made of this stretchable material, but they will be in the future.